For these last couple of problems, we're going to use the graph of the derivative of the function to identify the open intervals on which the function is increasing or decreasing, and then find any relative extrema. We'll justify our answer using derivatives. So notice we're given the graph of the derivative. This is f prime of x. It is not the function, yet we're supposed to tell where the function, that's f, the function is f, is increasing or decreasing. Well, remember we can use derivatives. What do we look for first when we use derivatives? We look for where f prime equals 0 or where f prime does not exist. We're going to be looking for these places to find the critical numbers. So I look along f prime graph where this graph equals 0. So where this graph equals 0, the f prime is right there. Is there any place where this graph, f prime, does not exist? No, it looks like it's continuous everywhere. There's no holes or anything. It has arrows. It keeps going. So I have a critical number right there. Now, so far we've been using number lines because we've been dealing with functions without graphs. Let's transfer this information into a number line. That could make it a little bit easier. So I have my one critical number. So remember, these are our critical numbers, or these give us our critical numbers. Excuse me, these give us our critical numbers. And we see the critical number where f prime equals 0 is at 2. So before 2 and after 2, we need to determine what is happening in the function. Where is the function increasing and decreasing? So before this critical number, the derivative f prime is above the x-axis. So all of these y values in the graph, in this graph, are positive. This is positive almost 1, this is positive 2, positive 3. All of these are positive values. So f prime is positive before this critical number. Now let's check out after the critical number. Well, these values are below the x-axis. So everywhere after this critical number to the right, I have negative a half, negative 1. These are all negative derivative values. So my derivative is negative after 2. Let's use our derivative to tell us what the function is doing. So the derivative is positive before 2. So f of x is what we're describing, and we can say that f, or f of x, is increasing on the interval negative infinity up to 2 because the derivative was positive there. So because f prime is greater than 0, or we can say f prime is positive. After our critical number of 2, f is decreasing. So from 2 to infinity, f is decreasing because f prime is less than 0. So we see there's a change from f increasing to f decreasing. This is a visual of what f will be looking like, increasing to decreasing. So we know that we have a relative max. So we can also say f has a relative max of, now I don't know the y value, but I know that it happens at that x value. So I'm going to say f of 2 because I know I have to plug 2 into the function f to get the y value. And then I'll say because f prime, what f prime is doing is changing, f prime changes from positive to negative at x equals 2. Let's look at one that seems to have a little bit more information in the picture. So once again, this is f prime of x that we're looking at. So we want to start with the critical numbers, and the critical numbers are going to be where f prime equals 0 or where f prime doesn't exist. Now once again, this is a nice smooth curve, so I'm not going to have any place where f prime doesn't exist, but it looks like I do have f prime equals 0 at 2 locations. F prime crosses the x-axis there and there, so it looks like 1, 2, negative 3, and at x equals 1. Once again, if I change it into a number line, negative 3 and 1, then I can have a better idea of how I did those other problems. So now let's figure out what f prime is around these critical numbers. Maybe you can pause the video from here and see how you do trying it on your own. So here in this section above the x-axis, and later above the x-axis. These parts both above the x-axis, so positive values for f prime. Then we're looking between these critical numbers. I see negative values because it's below the x-axis, so negative values there. So what does this tell me about what f is doing? F will be increasing when f prime is positive, then decreasing, and then increasing there. So I can say that f increases on the intervals negative infinity to negative 3, and then again union 1 to infinity because f prime is greater than 0. Similarly, f decreases on that interval where f prime is negative, so negative 3 up to 1 because f prime is less than 0. And now we have two places of relative extrema. At the critical number, at the first critical number, we have a relative max, second critical number, relative min. So f of negative 3 is a relative max because f prime changes positive to negative at x equals negative 3. Similarly, f of 1 is a relative min because f prime changes negative to positive at x equals 1. Once again, notice we're not saying it, we're saying f prime, or we're saying f.